So this next to last one, number 17, was also hard for a lot of individuals and teams. And this analyzing the optimal quantity of a public good is one of the key tasks in chapter 14. And it figuring out, we know that the rule for the optimum should be offer the quantity where marginal social costs equal marginal social benefit. We talked about why that's efficient. Every unit of the good that's valued more than it costs should be provided. None that is valued less than the cost should be provided. Well, what's the social valuation given we have three people? Well, the key here is that this is a public good. It's non-rival. So the benefits of the first one would accrue to citizen A, B, and C. If the good is offered at all, everybody gets to enjoy it without diminishing anybody else's use. So we get the market, the marginal social benefit curve, the market demand curve, by summing the individual demand curves vertically. We've always summed them horizontally before. So if we have price on the y-axis and quantity on the x-axis, and we have 0 to 50 as our quantities, the way we get from three straight line individual demands to a market demand is to remember, if we're summing straight lines, we're going to get a straight line. And since the first person, let's just think of where the y-intercept would be. For the first person, that first fragment of a good would, the first person gets 6, second person gets 5, third person gets 10. So 6 plus 5 from 10, 21. So we have a y-intercept of 21. And then notice that at 50, citizen A gets a benefit of 1 from the good, and then citizen B and C get a benefit of 0 from the good. So the market valuation is 1 plus 0 plus 0. And so that point is our y-intercept. And then it's a straight line. That's as close as I can come to a straight line. Well, we can map, let's look at quantity 40 and see what this coordinate is. We know that this is our marginal social benefit function or marginal social value function. We know that the optimum is where marginal social benefit and marginal social cost intersect. So I gave it away, that's at 40. But let's just verify that. We notice that individual A gets 2 units of benefit at 40. Individual B gets 1 unit, 2 plus 1 is 3. And individual C gets 2 units, 3 plus 2 is 5. So the y-coordinate at 40, x equals 40, q equals 40, the p-coordinate is 5. And so that's our optimum quantity, and the answer is D, 40 units.